what a day! What a lovely day!
Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you're new to this channel, or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside each of these shows while they're live, and there's also a PayPal link in the info box below the video once it's rendered. But most importantly, if you would like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the discussion and express your views on the shape of the Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcomed back on the next stream. Please also share the show. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel. So please share the show. And one last time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now we are joined by The Plain Truth, I think it's SX, Spurs Schemo, Sleeping Warrior, Mark Doxy, Jose, Chris, and Chocolate Saying. Good to have you all.
Good to be here. It's hard work, though.
Yo.
Hello.
Hello.
Morning.
Right, I want to ask the panel again, do you agree with Newton's first law of momentum, that something will remain at
No.
rest? Okay.
We agree with it, but what our issue is, how are you applying it in this instance?
I'm not
I have
applying
an
it.
addendum.
Well, one at a time.
Let me carry on. It states that something will remain at rest unless acted upon by an outside force.
I have an addendum.
Well, that's not Newton's law then, is it? You're
Right,
saying
so
that
now I disagree based on our chat in the between the shows.
Yeah, and I disagree too.
Okay.
It goes further than that. That's an oversimplified position.
Okay, all right. So it's true, but not always.
Well, it depends on how you apply it.
Hello, Michael. You a
No,
real
I'm
person?
applying it with
Hold on.
what it's.
Hold on.
Take it.
Hello, Michael. No, he's gone
Hello,
straight on
Michael.
mute.
Hello.
Oh, sorry.
Oh.
I've ejected you.
Oh, mate.
Mark, try to be more specific. what object?
Excuse me. How did you start that conversation and try to be what?
More specific, he said.
Yeah, be more specific, Mark. What are we talking about that is at rest? Exactly. Because we established that the plants are not at rest, right?
No. I'm starting again with Newton. He says that anybody will remain at rest unless acted upon by an outside force. Now, some of us after this discussion are saying, but there are certain exceptions to it.
Yeah,
I'm sticking to it. That I accept it. I can prove it. I've done experiments at school a long time ago, but experiments at school that something will stay at rest until acted upon by an outside
But
force.
give an example, Mark. Give an example. Like take a bowling ball, a snooker ball, a football, a coconut. What are you talking about?
I can't believe you're saying that anybody will remain at rest unless acted upon by an outside force.
Yeah, but what's your point, though? What is the point? What are you trying to say?
So once something is moving, it has been acted upon by an outside force. I also demonstrated or discussed that if something is moving in a particular direction, then the force that made it move was also sending it in that particular direction. If I see something falling, it's coming in a direction. If things, as Newton says, will remain unless acted upon by an outside force, there must be an outside force sending things earthward.
That's why I have an addendum.
Yeah, but you cannot prove that, right?
Hold on. Hold on. Travis was in the queue. Go on, Travis.
My addendum is an object will stay at rest unless its environment changes. What this does is it places the issue upon the mass of the object, because an apple will remain at rest even though it's growing, even though the wind is blowing, whatever we want to say. When that apple grows to a certain mass where its stem can no longer sustain that mass, it will fall. Therefore, there's a change in its environment, but there's no force. It is its own cause.
And just let me add to that. Hang on. Let me add.
Hold on,
Wait.
Anthony. Hold on. I want to give God. I just want to give a gap between each, so there's not like a bombardment for Mark to deal with.
Can I reply to that?
Yes, please, Mark. Do.
Right. We can all say that if we see something moving in a particular direction, that we can show where the power and direction came from.
No,
Yeah.
that's not true.
Yes, yes, he's right. So the
No,
coconut.
not Spurs. Do you know what the Magnus effect is?
Go on, explain it.
The Magnus effect is where you put an unbalanced force on an object at pace, and it creates an erratic effect based on the erratic application of a force. So, in other words, a football player that kicks a ball in a particular way can make it do what's it called, a knuckleball?
Yeah, but that's not the natural world, though, Anderson. We're talking
Yeah,
about
but the Magnus effect is a force that is not a normal force that he's describing. He's relying on a perfect force with no other external forces or conditions to influence it.
So do you not trust when you see something coming in a direction, you don't actually trust that it's actually coming from that direction initially?
No, absolutely not, because otherwise goalkeepers would save every shot.
And if you put a spin on the ball, it was a deliberate force that you applied to it.
Correct.
It's not a natural force, Anthony. It's
No,
like
but
a,
it is. Yeah, but
things remain stationary unless acted upon by an outside force. No,
because remember, Anthony, the player's trying to trick the goalkeeper. So if the keeper knew you were going to kick it to the left, and
yeah,
he
but Mark was going to use a snooker ball to show that the force is perpendicular to where it's come from, right? And that makes sense with snooker. But it only makes sense with snooker, which is a lateral force, it's not up or down. But you can show other forces that are not like that, and you can't tell where it's come from. Wind, for example.
If we did a dozen experiments where we applied the independent variable and the dependent variable, so we only had force going in one direction, we would show that when you hit something that's stationary, it'll go in that direction.
No, that's not true.
It is true. It is true.
Hold on, I don't want to get away from his point of how the object.
You can carry on for the sake of discussion, but I don't agree. The Magnus effect proves that that's not true.
I still think my brilliant addendum has not been addressed.
Well, I want to support that. I got stopped before. That's the same thing with the egg. When the egg was sat in a suspended state in the middle of the glass bottle, a little bit of salt was added to the environment, and then the egg changed place.
Hi, Marlo.
Hello.
Hello.
Hi, folks who are adjacent. So the egg will remain where it is according to Newton's first law unless acted upon by an outside force.
I have a problem with that.
So if the egg started to move to the left, the right, or down or up, it's because there's a force exerted to it.
No, the environment has changed.
Yeah.
If you flip,
Hold on, can you just let SX get his words in? Go on, SX.
Yeah. I have a problem with that theory because you realize that implies that that things will float if you don't have a force, right? Therefore, you must have a force.
Say that again. Are you talking to me or other members?
I'm having a problem because I don't speak English pretty good, but sorry. That implies can you repeat that the theory of Newton, first law?
Well, Newton claims, and I believe it because I've experimented with it myself, that any body will remain where it is unless acted upon by an outside force.
I think the main question is why did the apple fall from the tree? So you're implying
hold on, Spurs.
that there was
Hold on.
a force.
Hold on. We've got a back and forth between Essex and Mark. So just let that. If he's got no further points, then fine.
Well, that was exactly my point.
That is the point.
The apple is that he assumed that there's something pushing it down, other than just its weight.
If I see
can I explain it to him? What it is that an object will not move unless there's a force applied to it.
If I see a moving object, I know there's a force come from somewhere else that made it move. Is that a fair?
Well, Mark,
no.
Mark, hold on, Milo, please. Mark, look, we just need to know why the apple fell. We're saying it's because it grew, so it's obvious that it cannot hold the stem. You're saying it's something else. Why doesn't that make sense to you?
But hang on.
Because it growing does not explain the direction it's falling, and it doesn't explain the rate of fall.
No, hold on. How did the apple get there in the first place?
It doesn't matter. It doesn't matter.
Well, it does matter. It does matter. That object. Hold on. things do not appear out of thin air, do they? So they don't just appear and then fall. So how did the apple get there in the first place?
Right.
Energy,
It grew.
energy from the sun.
No, but it started from the ground.
Right.
It grew. Yeah.
Okay.
So it grew. It grew
So,
too large for the stem, as has been stated.
right.
Too heavy.
Mm-hmm.
And then it fell.
All right. So now, what explains the direction it falls, and what explains the rate of fall?
It's going back to the source. So it's like the seed.
No. What explains the rate and the direction?
The answer is density. That's the
answer. But the density around the apple is less, up or down. So why doesn't it go up?
And that direction is
because density.
And
but why doesn't it go up? Because it's less dense. The air around the apple.
The surface of the apple. Yeah, the surface of the apple and the atmosphere, do not coexist. It's not like a sticky enough substance, like we were discussing bubbles. They fall slower. Why? Because the atmosphere around them has an attraction. So there is no attraction.
But it's defying Newton's first law. If it starts to move, what made it move?
No,
exactly.
it isn't
its own weight.
Hold on,
no,
hold on for the whole panel.
Dude,
sorry, Milo. Just hold on, Milo. Just hold on, Milo. Hold on for the whole panel. So as I understand it so far, the argument is that you can't use an apple because it's never not in motion. It's always growing, therefore increasing its potential energy that it stores as it grows, as it converts energy from the soil and from the sun and from water. So therefore, it's not an object at rest. It's growing up, and therefore, when it gets to a density that's more sustainable than the twig it's held by, it falls back to where it came from because it is more dense.
No, that's the thing. First of all, potential energy, you can't speak about potential energy without a force. You understand that? And you can't talk about density without a force as well.
No,
density is not a force.
That is our argument.
Why not? Hold on, Spurs. Hold on, he's just telling us what we can't do. So tell us why we can't do that, Milo.
Okay, so how do you calculate for potential energy?
No, don't ask me something. Tell me why we can't do that. Why can't I say, as I pick something up, it then has potential energy, and then say no more? Right. Why can I not do that?
Because the way you calculate for potential energy involves forces.
Sorry, I didn't ask about any calculation. I asked about an assertion about me picking something up.
You're using a physics term. And you're trying to ignore the calculation that's attached to it.
Sorry, so you're saying I must... Hold on. So we must use your calculation?
Well, do you have one?
Oh, sorry. I don't have to have anything in order to smash your assertions to pieces. So we have to use your mathematics? Is that what you're telling me?
Our mathematics predict the potential energy.
Sorry, hold on. Did you say the word predict?
Yes.
Oh, excellent. What's the hypothesis?
What's the hypothesis for potential energy?
Why are you laughing? What's the hypothesis? You just used the word predict.
Well, you'd have to give me a scenario with the weight of an apple. And
sorry, I'm not the one who said. I'm not the one who used the word predict. So in science, there's a special kind of prediction. It's called a hypothesis. Now, if you're going to, can you pop yourselves on mute if you're not talking?
We're talking about math now, though.
No, we're not. That's my point. You're telling us we must use your maths, and so far you haven't given me a justifiable reason why. And if you're saying because we've got predictions, well, in science, something that studies the natural world, not mathematics, a prediction is a hypothesis. That's why I asked you for it. We're not talking about maths. We're talking about the natural world. Okay, Milo? So, just to clarify, do you have a justifiable reason to force me to use your maths?
It's the same principle that tells you speed times.
Don't tell me what it does.
Time.
Shh.
Shh.
You're ignoring my question. Give me your justifiable reason why I must use your maths.
Because you're using a mathematical term.
No. I said I picked something up and I gave it potential energy. Now, you may have decided that has a mathematical formula around it. I'm just using that term because that is a colloquial term.
Potential energy is a colloquial term?
I'm using it colloquially, yes.
What's the colloquial definition?
Don't ask me something. Tell me why I have to use your maths.
Well, you just asserted that it's a colloquial term.
That doesn't answer my question. Why are you demanding that I use your maths?
Because it's not a colloquial term. It's a scientific term. It's a mathematical term.
Right, so you're saying because we use the words potential energy, those terms are yours and we must use them in context of your science with your maths. That's what you're saying?
There's only one context which you can use potential energy in.
Okay,
no
well,
other
so
context.
what you're saying is we must say I've raised the weight up rather than I've given it potential energy.
You've raised the weight up. You're still left with the question: why does it fall at a certain speed, and why does it?
Well, I can answer that for you.
Fall down?
It's more dense than the air that it's been raised up through.
Density doesn't explain the speed, the rate.
So we're not trying to explain the speed or the rate. We're trying to establish if there's another force other than weight.
Exactly. How do you establish?
What do you mean
that?
exactly? You haven't told me other than to say that I must use your maths. So tell me why.
How do you establish?
Don't ask me anything. You still haven't established anything other than telling me I've got to use your. Other than telling me I've got to use your maths because I've used a certain word, you've given me no reason to use those mathematics.
Well, you're using the term potential energy.
I won't use potential energy anymore. We've raised the weight up.
Okay. All right, you've raised the weight up to a certain height, right?
Yep.
You're still left with the question: why does it fall at a certain speed?
Why am I left with that question?
I
can calculate the speed it falls at, so that's fine. We can calculate that.
How?
What's the relevance? We're talking about a force. You're asking me about calculating terminal velocity.
No, you're trying to isolate the force.
What force?
You understand?
What force?
The force that's causing the mass to accelerate.
Well, that's its density. That's its density because we raised it up. So I picked it up, I increased its height, and its density is then out of equilibrium. There is something less dense than it between it and where it originally was. So it would have been at perfect rest had I have not picked it up and increased its height. Its mass is greater than the air that sits between it and where it was at rest. Therefore, when I release it, it went down. So you tell me where any other force comes into that explanation.
Because the density of the object doesn't explain the direction the object is falling and doesn't explain the rate at which it falls.
Why do we need to explain the rate? I can calculate the rate at which it falls, but why does that need an explanation?
It needs an explanation because you're trying to isolate a force.
Don't just reassert it. Why does the rate, which I can calculate, now need an explanation? It's just a rate that I can calculate.
Yeah, so then when you try another object with a different density, you find out that the rate of fall is the same. So then you're left with the question, why do they fall at the same rate?
So if I drop a feather, it falls at the same rate as a bowling ball?
If you remove all the variables, yeah.
Excuse me, if I drop a bowling ball and I drop a feather, will they or will they not fall at the same rate? Shout out to the mind of God for the super chat. Yes or no? Fall at the same rate? Yes, that's what you've asserted.
Vacuum, yes.
So,
vacuum,
sorry,
yes.
What the hell are you talking about in a vacuum? Where's this word come from?
Because you're trying to isolate the
Excuse
force.
me, I'm just asking what happens when I drop
Air is
something.
a variable.
Why are we isolating things? Are you now telling me that I've got to use science? I've already explained that you've demanded we use... Excuse me, you're talking while I'm talking, Milo. Do it again. You go. Simple. You've told me that we must use mathematics because I've used a particular word. Now I've said, no, that's not scientific, mate, that's maths. Now we're on to you telling me that you're doing something scientific by removing the atmosphere that I need to breathe when I pick this thing up. How am I going to breathe it? How am I going to breathe when I pick up that thing? The bowling ball and the feather, how do I breathe when I pick them up?
Well, Nathan, do you want to reach a point where you isolate any variables or no?
I'm not isolating variables, I'm just picking up a feather, mate. What,
so then
you
if you
don't,
never
hold on,
isolate
hold
any
on,
variables,
we're trying to
come to a conclusion.
establish... Well, hold on, mate. You've already declined. When I asked you for a hypothesis, you were like, "What? Why do I need a hypothesis? Got a mathematical formula." Now you're demanding that I isolate variables. Why are you demanding this of me? Why is it that you think you've got some scientific justification to tell me to remove the very air I breathe? Are you an idiot?
Look, I cannot
What
prove
part of I don't breathe a vacuum when I pick up a feather and a bowling ball don't you get?
What part of you cannot isolate the variables?
Excuse me, who is isolating anything when I pick up a bowling ball and a feather? Why are you suddenly putting me in a deathly situation in order to just pick up a bowling ball and a feather? Why do I suddenly have to risk death to do this? I don't get it.
Can I ask a question?
No.
Yeah,
why do I have to risk death? We've got an example of us picking stuff up. There's no vacuums being talked about till Milo got on the panel. So why am I now risking death in this example, Milo? I don't get it.
Because you're trying to isolate.
I'm not isolating anything. We're talking about mathematics. If we're trying to isolate things, no problem. I'll put the shoe on your foot. You've done it enough. What's the hypothesis for this reason for isolating variables? What's the hypothesis we're experimenting with? Excuse me. Give me that right now.
If you control variables.
No,
like
not
air.
the control. Don't tell me what it is. Tell me what the hypothesis. What the hypothesis is. Don't tell me what a hypothesis actually is, but what your hypothesis is for necessitating isolating variables.
If you want to isolate the force, you have to control variables like air that might affect the rate of fall.
Okay, so give me your hypothesis. Third time. What is the hypothesis?
I was explaining it the first time you cut me off.
Go on then.
So can I go through it? All right. If you control for air,
not if I control for air. A hypothesis takes the form of if and then. If this, then that. That's your hypothesis. If you want to expand on that, you can give it me in the form of a null as well as... Oh, my kid's climbing all over me right at the wrong moment. You can give me a hypothesis for what's going to happen in this experiment. The reason why we are isolating variables. Give me the hypothesis for the experiment which requires I suddenly am in a deathly situation. Give me that hypothesis. Not what a hypothesis is.
I'm not telling you. I'm telling you. Are you going to let me get through this or what?
Yeah, I'll break it down. Give me the independent variable in this hypothesis.
The independent variable is the objects.
Sorry. So if objects... So our independent variable, the thing we're going to manipulate, the cause of this effect is objects.
Or the mass of the objects.
Right. So there's your cause, mate. So before we do anything else, I've got your cause. It's mass of objects.
Wait, I have to think about this. Hold up.
What do you mean, hold up? Excuse me, Milo, repeat after me. Repeat after me, Milo. My cause in this cause and effect...
No, actually it's the lack of air.
Shut up! Shut. One more time, Milo, you're going. You will repeat after me. The cause in my science is mass. Repeat after me.
No, I was wrong, actually. Because that's not what I'm controlling.
Sorry, you just told me what you were controlling. You told me what your independent variable was. You were very clear about it. Yeah? Objects. Yeah, a bit of a dumb answer because you're a dumbo. But you then corrected yourself and then said mass. So, the cause is mass. Repeat it. You said it first. I'm now repeating it back to you. I'm going to get you to confirm. I'm going to get you to confirm your nonsense. So far, we've had an independent... Right. Goodbye, Milo. You cannot shut your mouth. Get out. Pathetic twat.
And Milo got wrecked.
Right, I'll just summarise. Milo told us that we were doing science by putting ourselves into a vacuum and near-death situation so that we can pick up a feather and a bowling ball. No idea why. Apparently, then he tells me that we're isolating variables. And I ask him what his independent variable is in this science. And he explains that it's mass. Exactly like Rumpus did yesterday. So our independent variable was mass. No gravity, just mass. Okie dokie.
He flipped quick and he put it on YouTube giving a just so story like the ones they give us.
And I don't think they have done these experiments for themselves. I just think they're repeating what they saw from these guys. That's the problem. And that I was gonna ask him that if he has done this experiment by himself or if he's just like a parrot, just repeating.
I'm pretty sure Milo has no experience with a vacuum.
Can we go back to Mark Doxey?
If he's willing. You there, Mark?
Yes. Yeah, I'm still here. Yeah.
Do you want to bring up any definition of force in physics that you wish? If you don't want to, I can do it for you.
Well, it wouldn't be mine, then, would it?
Well, some people don't want to do it.
A force would be an exertion of energy.
Right. So let's bring up a definition. Just pick one. Let's get it on screen. Definition of force in physics.
No, you just included something else there, haven't you? A definition
of force in physics.
No, that's not what you asked me. Just put a definition of force.
Well, if you narrow it down to the physics definition of force, it might help us. You can go with the generalized one if you wish.
No, it'll help you to get you to your punchline, but I'm just saying you changed it just at the last moment. So the definition.
I don't care which one you go. Just present your screen.
Hello.
Hi, James.
Hey, James.
Hi, Jimbo.
Give me your definition. Go with your flow. Go with your flow. Go on.
So okay, so all I've done is I've typed in a definition of force in physics. Nate, do you want to present my screen?
Sure. You're up.
So it says, I mean, tell me where we're going wrong with the application, because I can identify.
No, you tell me your conclusions. Don't go Socratic. Don't go Socratic with me. You just tell me your conclusions.
Well, my point is that I think that you're misapplying the definition, and I'm going to show you where you're misapplying it from, and you can correct me where I'm going wrong. A force is any interaction that, when unopposed, will change the motion of an object, but it requires that. Well, it hasn't defined it yet. A force can cause, that's the bit that's important, cause an object with mass to change its velocity. But what's the cause if you haven't got a force that you can identify?
Well, there's 9 different forms of energy. So there's 9 different forms of force.
Right. So can you show me an object that sorry, let me rephrase. Can you show me an object with mass that will change its velocity or its direction of travel without a cause being applied to it?
No, I can't. That's Newton's first law. That's absolutely right.
Right.
Okay?
So
if I see something moving, then it has received a force to make it move.
But can you show that there's a force been received?
If there is work at the end of it, then there's been a force somewhere along it.
Yeah, but it's the word cause that's the issue. Can you
Okay.
show that there's a cause? Because we all see the effect. We all agree that it moves down or whatever. It moves in whatever direction, right?
No. My argument to you is if we see something moving, then it's had a cause exerted to it.
Yeah, but you have to show the cause.
Okay, will you explain to me Fleming's left-hand and right-hand rule?
So
that's all to do with electric going down a copper wire.
So when it goes one way, it creates a field that goes clockwise. When it goes the opposite way, it creates a field that goes anti-clockwise. I can't remember which way around they go.
Yeah, it's something like that, isn't it? Yeah, but you see, you cannot see that, but you
but you
it's
can
there.
Identify the cause.
Because you see work happening at the other end.
Yeah, but you can identify the cause because you can do different things to identify that there's electric passing through it or not.
Yes, you can demonstrate because there's an action at one end, there must be a force at the other. The force has got to it. But we cannot. We cannot explain.
It's funny to me how every example and demonstration of gravity at work involves using energy to lift an object in order to drop it to prove gravity. A mic in your hand, feathers and bowling balls with lift trucks. You know, it don't matter. It always involves exerting force to get an object in the air, or some pre-existing, like an apple growing in a tree or a coconut growing in a tree. Energy goes into that. That energy, stored potential energy, has to go somewhere. It's growing over a superfluid that's not very dense, and it's pretty dense.
If we could create,
right, it falls off. Boom, goes down.
See this bit here, Mark?
It's not rocket science.
Just real quick, guys. Just real quick. Let me. I hear you discussing something that's man-made. We have a man-made construct to conduct electricity. So we are creating the force, the potential for this force to work. Are we? So let's not talk about electricity because we have to manipulate those variables. So we know the source, we know the work, we know the product. Okay, that's something that we have to manipulate. We are, I think, rather talking about something in nature that we have to discern. And we're saying that if we cannot see or understand the source of the force, then we can't discuss the force itself. So going back to
the problem here is that when it comes to electricity and magnetism, gravity has nothing to do with them, and it's not even included in any electrical or magnetic calculation ever.
Say that again.
So there you go. Pretty wild.
Right. Listen, Carrie, have you got to your punchline, Anthony?
Yeah. So are you still looking at my screen right now? So in this example, there's a book on a table.
Yes. Okay.
And it's identifying 3 forces. It's saying it's saying that these forces are acting on the book, and they're not balanced. Okay, so we have a movement. We all accept that there's a table that's pushing backwards against the physics book because it stops the book from falling to the floor. So we can see the table is the cause of the physics book stopping its movement. We all agree with that one, yeah?
Well, you've introduced the third law there. Well, carry on with where you're going with it.
The friction between the table and the book we can demonstrate by heat that's generated between the physics book and the table itself. If you really wanted to, you could measure that somehow.
Yes, I agree with that, yes.
How would you identify the gravity pulling downward on the book?
Well, now, see, you've introduced something there that you agree with and I don't agree with. Well, it's the other way around, actually. All the aspects of gravity, I don't accept. My argument to you is that if a mass is moving, something caused that mass. Now, you're talking to me about force. Everything's gone quiet. Are you still on, yeah?
Yeah, it's the cause that's the issue.
Right,
how are you going to show cause?
Here we go. There are 9 different forms of energy. Light, electric, atomic, sound, magnetism, kinetic energy, potential energy. I've mentioned light twice. Chemical energy. There's one I can't remember.
Gravity?
No, absolutely not. All these things make things work. Now, you cannot create energy and you cannot destroy it. You can only pass it from one to the other. But there are a number of these that we cannot actually see physically, but we can see the work of what's happening at the end. And therefore, we conclude that that's what caused it. We don't understand light. We don't understand electric, atomic energy. We don't understand, well, with sound, yeah, maybe. Magnetism, again, cannot be explained. It's there. It causes things to happen. We understand kinetic energy, we understand potential energy, and we understand chemical energy.
But give me an example of any of the list that you've just said where a cause can be evidenced without the object doing it. So magnetism, show me magnetism without a magnet. Show me light without a sun. Show me sound without a speaker.
Yeah, these are all forms of force. I'm not denying that. You said to me today that if you cannot see the force, then it's not there.
Well, you have to prove it's there, right? Not necessarily see.
No. If you see, come on, you're legally trained. If you see an effect, there has to have been a cause.
Has to be, yeah. So how are you going to identify or demonstrate the cause in this case being gravity?
I'm saying to you that certain forces we cannot explain, but we know they are there.
Give me one.
Electric.
So it comes from a transformer or a power station or a plug socket?
A transformer is using kinetic energy and magnetic energy.
Yeah, but my point is we can identify a source from where the electricity is coming from.
You cannot explain how it works, though.
I'm not an expert in electricity, but I know that if I plug a plug into the wall and then touch the prongs of it, I'm going to get a shock.
If your hairdryer is blowing hot air on your head, you know that it's working and it's worked by a force.
Yeah, but it won't work if you don't plug it in. That's the cause.
Exactly. What I'm saying, no, your argument to me yesterday was that if you cannot see it, it's not there. I'm saying to you,
you've got to prove right.
If there's work happening, you cannot get nothing.
Prove causation.
No, stop. Let's stop. Please, let's stop. We have to give in this discussion right now. We have to go back to the coconut because this is where I was with Mark. We have to have an observe. Because
don't deny the coconut. You've got to go back to the coconut, and I'm definitely going to allow it.
If work is happening, there is a cause of that work. Whether we can explain it or not, whether we can.
No, unless you can show cause, you haven't got anything. You have to show that there's a cause, not the effect. That's Darwin's argument. Show me the cause. Otherwise, it's not a force.
If we're talking about a hairdryer, we're not talking about the physics of what this podcast is about. Okay? We can't talk about hairdryers. We can't talk about electrical transformers. That is a completely other phenomenon.
Yeah, it's technology.
Is the coconut in the tree or on the ground at this point?
Energy creates force. I was asked whether I had a definition of what force is. Energy creates force. If I see something working.
No, it doesn't.
Energy does not create force.
No, energy is part of a force. but the energy has to. It says.
Well, this is
hang on. It says a force is any interaction that will change the motion of an object.
Yeah,
so energy by itself won't do anything.
But that's the work that's happening, isn't it? If something's changing motion,
No. Energy is not work that's happening. Energy is energy.
Let's go back. Let's go back to the hairdryer, right? You've got motion inside it, and when you switch it on, the little motor inside starts to move. So a force has started that motion.
Right. So what was the cause? What was the cause? Yeah. What was the cause?
The force that we know is electric, but we cannot explain electric.
Yeah, but we can identify that it's electricity, right? By turning the switch on.
We can manipulate it.
Yes, okay. And can we identify a downward force then? Because we see.
No, that's the point. You can't identify a downward force. That you can't contrast it against the density that we do explain, observe, and can prove.
Density is not a force. Density is a measurement. The force is a downward force. If I see something working, I know it's been caused. If I see a stationary object and it starts to move, it's been moved by a force.
Right. So prove that force.
I can observe it. I cannot prove electric.
Prove the gravity over the density.
No, that's not the argument. Density density is description of the volume of a unit and its weight. That's all it is.
Yeah,
we're still back to what I was trying to discuss with you, Mark, when I was interacting with you one-on-one. If you and I observe the falling of an object and I determine that it is due to its weight, and you postulate a second idea that has to do with something we cannot see, my question will be to you, how are you validating
this is what I'm because before I was stranded on that desert island with you, I did physics at school, and the first law of momentum is that something stays where it is unless acted upon by an outside force. Now you have requalified that to fit what you want it to fit. This is just the basic Newtonian first law of
yeah, but basic means that it does go further than that, right?
No, it doesn't. No, it's simplified, and that's it.
Oversimplified.
Not well, okay, but you didn't say that initially.
I did. I said the Magnus effect is one of the reasons why it's oversimplified. Do you not remember?
The Magnus effect.
Yeah.
Is multiple forces.
No, one force. One force applied in an unbalanced way will cause an erratic result. Magnus effect. It's the spin on a football. It's the obscure action that you kick the ball in a particular way, and although it's one force, you've done it in a particular way.
The swing of the leg, the angle of your foot, and whereabouts on the ball that you kick.
Correct.
That's not random. Skillful.
No, it's the application of the force that's asymmetric.
And the momentum of the ball was caused by a force. Somebody.
But the trajectory means that you can't tell where it's come from, which was your point earlier on, and I didn't agree with it.
But you can tell it where it come from.
No, you can't. That's the point. Look at the Magnus effect and then predict where it's come from. You can't.
No, but Anthony, if you hit that ball in the same place every single time, you're going to get the same results.
Somebody's taken a corner. A very clever footballer. He's able to put enough spin on it that it actually scores a goal without any of his teammates heading it in. That's the Magnus effect, yeah? Is that what you're saying?
Yeah, that's one example of it, yeah.
They can almost make a corkscrew effect on a ball. Incredible effect.
David Beckham could do this every single time. That's the point. He could repeat it. So...
Yeah, but it wasn't predictable. That's the point.
Oh, come on.
Come on, Anthony.
Otherwise, goalkeepers would save every shot. Look at the knuckleball. Look it up and look at the application of the knuckleball. It's the way they kick the ball causes it to do weird things in the air, and it's totally unpredictable.
Yeah, but the goalkeeper, if he knew he was kicking it like that every time, he would save it every time.
The ball was on the corner point, and it stayed there, and it will stay there until it's kicked by the footballer.
No. Can we go back to the coconut tree? Mark, how did the coconut get there in the first place?
I've answered that. Tell me what I said. I've already answered that. Tell me what I said.
Well, I don't get what you're saying because you seem to be like surprised that the coconut was in the air in the first place.
Oh, come on.
Well, you do.
There's a coconut and it's up in the air. Don't treat me like I'm a child.
Well, how did it get there?
Have you ever seen fruit growing on a tree?
Yeah, but
you see it in the spring. It's a blossom, and then a wee bit of sunlight throughout the summer, and you get a fruit at the end of it. The leaves fall off. This is all observable. The leaves fall off. no more photosynthesis. There's a decay on the stem, and the fruit will fall.
Well, look, Mark,
No,
everything.
that's not the cause. Decay in the stem's not the cause. The mass of the growing fruit is the cause.
No. Once the stem has deteriorated.
No, it doesn't do that while it's connected.
What happens in the autumn? What separates the fruit from the tree?
It's mass.
No, decay first of all. Otherwise,
no. While it's still connected, it's getting nourishment from the tree. Its mass gets too big.
The leaves have all fallen off, so there's no more nutrients. So
yeah, but the fruit
Mark,
gets.
Right.
So
Okay.
Mark, once that branch snaps, right?
Yes.
Once it snaps and the coconut for like that microsecond is just hovering in the air, now it's heavier than the air, right? So it falls down.
Why does it fall
right?
down?
So
where does Newton's
heavier
first
than
law,
the air?
Where does Newton's first law come into this? A mass will stay where it is.
Attached to the tree, it was a body at rest, technically. Stored engine, stored energy.
Gentlemen,
the environment,
and also
changed.
No, hold on.
And now it's
hold
no
on.
longer.
Hold on, I want Travis to pipe up at that point. Please, can you repeat your addendum, Travis?
My addendum. Can you hear me? Okay, I'm on my truck Bluetooth now.
Yes, go ahead.
Okay, so my addendum is that an object will remain at rest unless its environment changes.
Also,
or
listen,
an outward force is exerted on it. So that's my addendum.
Listen, come on, Travis. Let's get that in the history book. On the 8th of the 8th, 2018, there had to be an addendum.
Hang on a sec. In addition to that, Nathan also correctly pointed out that the fruit is not at rest because it's in a state of continually growing. So it doesn't satisfy the definition anyway.
But it's potential. It's growing in basically one location in a tree above the ground. Sure, it's moving around with the branches and the wind and all this jolly stuff. Fine. You want to say it's perpetually growing, so it doesn't count as potential energy? Wrong. It's still potential energy that's increasing.
Once
it snaps, Mark's question was, why did it fall down? And it fell down because once it disconnected from the branch, it's in the air, and it's heavier than the air, so it falls down. So it reaches the ground. Now you're trying to say there's another force besides its own weight in the air, being that it's denser than the air.
Who are you addressing that question to?
You. Addressing you.
Say that again. I don't think I did say that. Say that again. I'm not saying because
you
of
asked before. All right, but you asked before, why does it fall down?
No. I'm not asking why it falls down. I am observing it falling down, and with every other experiment.
You asked me why it goes down.
Yeah, my argument when I started was that if you see something moving, you've got to ask yourself, why is it moving? Because it received an energy from something else. When it's going in a particular direction, that energy was exerted to it in that particular direction. So when a fruit, which should stay where it is, unless acted upon by an outside force, not because it's let go of the tree or the tree let go of it, it should still stay there. But if it starts to move in a particular direction, what was the force that made it go in?
How can it stay in this?
So
how can
you're
it
just
stay in
going
the
to take
atmosphere?
away the weight.
I'm looking at an empty glass on my table. It's staying there, and it will stay there until I move it.
So without gravity, mass would levitate, is what you're saying.
No, it would stay there.
That's levitation. Once it's
attached
to the
levitate,
levitating.
But Mark, how can it stay there if it's heavier than the air that it's in?
It doesn't matter. Every object has got
mass. How does that
not
matter?
Because you're misunderstanding the first law of Newton's laws of momentum. It's a mass, and it'll stay there.
I think that's why Travis came up with his addendum, because something changed. It's no longer at the point that it was before, where it was connected to the tree. Now the branch broke. Now it's suspended in the air. Now it's a completely different scenario.
No, it's not.
Now it has to move.
It's a mass that exists in a particular place in the universe. And it will stay there unless acted upon by
LOL, it's a coconut in a tree.
Yeah. coconut in
football,
a tree,
the
and
football
the
that's in
branch broke, so it
Star
falls
Trek
down
dimensions, a
because it's
coconut in a
heavier.
tree. Yeah, to apply some fictitious force that was created 200 years ago, or whatever. Because it is a fictitious force. Gravity, that's a unicorn.
Who's saying that?
You can always add more fiction to fiction. It's not impossible.
Who said
I'm
that?
just trying. Mark. I just trying to get you to. I don't know. I'm trying. You want to identify another force besides just the reasoning of it being heavier than the air. You
I
want
want you.
something else? Is that what?
No, it's not.
I'm
It's
kind of
nothing to do with
confused.
how heavy it is. A ball will
Okay.
stay. A ball will stay on the corner point of a football pitch until it's another force of energy is given to, and it will go in the direction that the mind wanted it to go into. The guy that kicked it. When you see something moving, it started at rest, and it's moving because of an external force. That's the basics of Newton's first law. Now, you're all at the beginning. Most of you said yes, you agree with it, but now you're having to fine tune it because it doesn't fit. You cannot cope with the fact that there is a downward force. It's not the big gravity thing. It's nothing to do with Newton's gravity or Cavendish or Einstein. I observe when something is moving in a direction, it was caused by another force.
No.
All right, let me.
I know you're not. I know you're not agreeing with that. I know that, but density does not explain that.
It does, absolutely. There is no further requirement other than the density of the weight itself in the environment it's in. No further explanation is required. But you're demanding that one gets put there, and I'm like, well, prove it.
No, I'm not demanding anything. You said to me yesterday you were going to demand that every time I use the word downward force, you're going to pull me on it.
Yeah. So prove the force.
Because I see momentum. When you see something moving, it started at rest and it was given momentum by an outside force.
But why is that momentum not caused by its own weight and displacing the air below it? It's greater than.
Listen, I have a glass in front of me. It weighs what? I don't know what.
Okay, I
Six
think I
stones.
heard something. I think I heard something that I would like to address. So, Mark, if you did not have Newton's first law, if you did not have that that proposition, what would you say about your observation of the falling coconut?
What would I say about it?
I kind of agree with that question because you said before you got stranded on the island, you went to school, right?
Yes,
So
I
if you
did go to
hadn't,
school. But listen,
right,
we were given
to school, you would have the same.
Yes, I was in
background as Travis, who was born and raised on the island, right?
Well, yeah, okay. Listen, school enlightened me on physics. I loved physics, and we were given that particular point of that everything remains at rest until acted upon by an outside force, and we did a series of experiments or disprove it, and there was enough evidence to show that something will stay where it is unless acted upon by an outside force. And if the outside force is in a particular direction, then that body will go in that direction.
Right, but you have to understand that principle can't apply to every single instance. So that's why
clarify that.
I'm trying to. So as I'll do this the best I can, Mark. As I've listened to you, this is where I've come in the past minute to insert myself in this discussion. That is, I believe you are saying that there is a force pulling the fruit off the tree based on Newton's first law. You are already operating on a supposition, on a principle, so that principle influences your interpretation of an event. Now, I go back to ask.
No, I disagree with that. You can't go on to the next point. I disagree with that.
Okay, well, but that's my assessment. I know you can disagree with it, but that's my assessment of what's happening. The only reason, that's why I asked you, if you didn't have Newton's law and you had the same observation, what would be your deduction?
I might not even have noticed it.
Okay, you and I are chilling on the beach and we're both drinking coconut milk.
Yeah.
And we're talking about how the coconuts fall, and we're so glad because we're scared of heights, we can't climb up, and boy, I'm glad they fall. And now we start talking about how they fall. would you come up with a force?
I might do. If I smack you in the face with my fist, it's the force going in one direction, and
Yeah, but you can show the fist.
Yeah, right, yeah.
You can show the fist, but I can't show you my muscle moving inside me. But you will receive the force. What?
Mark, if something falls off a tree, how much of it is down to gravity compared to how much of it is down to its own density displacing the air around it?
What density is zero. Absolute zero. It's the gravity, the downward force that pulls it to the earth.
So it's 100% then. 100% gravity, 0%.
Yes,
density.
but I have to qualify the word gravity. I'm not talking about Newtonian or Einstein or Cavendish. I'm just saying there's a downward force. I observe that.
But you're saying that it's 100% down to gravity, right? Whatever it's defined as.
That, yeah, there's a force that pulls it down. Yes. Yeah.
So why do you reject density?
I don't reject it. When did I reject it?
Well, you just said it was 100%
zero.
gravity.
Yeah.
No. You said to me that something falling down is nothing to do with density. It's to do with gravity.
No, never. I asked you what proportion of it was down to gravity over density, and you said 100% gravity.
Yeah, there's no proportion. There's no proportion.
Right. So why? So therefore, you must dismiss density by that statement, right?
No, I don't. In your video last night, you showed a beaker with different coloured chemicals in it.
Correct.
The bottom one is down there because of gravity. The next one up above it is resting on it because of the density. But
we have numerical values.
It's still down there. The numerical values is maths. You know, that's a weak
we can measure the density of everything, right? Everything has a density value if you measure it accurately enough.
Yes,
right?
it's a figure. Yes,
right.
I know what density is. I know how it works.
So how much of the liquid at the bottom, not the screw, but the liquid at the bottom or the screw, whichever, you're saying that's caused by gravity, but that means that you're dismissing the density of the item.
Well, if you're talking about the density of the liquid and the glass beaker that it's in, there's still there's something else there to be explained.
No, you've not answered my question. You think that that's caused by gravity, whatever the definition of whatever you define it as.
Yeah.
By saying that it's caused by gravity means that you are dismissing the known principle of density. Why do you do that?
I'm not dismissing anything.
Mark,
so where's the line drawn? Hang on, wait. Where's the line drawn between density and gravity?
Two masses cannot occupy the same space.
Correct.
Oh, so we've got water at the bottom and we've got oil on the top. The water and oil, because of their properties, will not mix. So which one's going to go on the top? Which one's going to stay at the bottom? They're both going to stay next to each other because of gravity, but because they're two different densities, one will rest on top of the other.
Right, but you said it was caused by gravity before, but now you've just said it's caused by density.
No. Listen, you're trying to trip me up here. We were talking about the coconut falling down. Is it gravity or is it density?
Right, hang on. Members of the panel, did Mark just contradict himself or not?
I don't think that you're trying to. Yeah, I don't think you're trying to trip him up. It's just a very convoluted discussion, Mark. So I don't feel like he's trying to trip you up because I'm having trouble understanding you. I feel like you're double speaking.
Many oils are 0.95 grams per cubic cc. Water's 1 gram per cubic cc. Therefore, they float when they don't dissolve in each other, when they're non-soluble.
The one thing
I'm enjoying this more than our yelling.
The one thing I'd like to ask for clarification on, Mark, is that you said the fluid at the bottom of the beaker is there because of gravity.
It's being held in that position, yes.
But
not
when you
density.
Explained it, when he explained it, he said density, and that's when I said you've just contradicted yourself, and you said you felt like I was tripping you up.
Right.
Is that a flaw in my argument?
Yeah. I asked you, was it down to where was the line drawn between gravity over density? And you said it's 100% gravity. And I said, well, why do you reject density? No, and then when you explained it, you said it was density that was doing it.
Listen, if
the oil floats for the same reason a boat does. It's less dense than the water below it.
Yes, that's true.
Nothing different. No gravity involved. It's lighter.
I agree with that. If the water that the boat is floating on was suddenly aerated, the boat will sink.
Why is that?
Because of gravity.
No, because you've reduced
air.
You've reduced the density of the water.
Listen, let me go back to what I initially said and that everything will remain where it is unless acted on by another force.
It's not true, though. It's oversimplified.
Give me an example of something that does not remain where
The
it
Magnus
is.
effect on a football.
Oh, come on. We know that there's an intelligent mind. There's somebody that's got muscles and a leg and a foot, and he knows where to hit the ball. That's not.
Right.
That's a non-argument. You're going to have to take that
what
away.
you're doing now is mistaking the prioritization of causation. There are many different different factors that affect causation.
Why is the ball moving?
Where is the intelligent mind telling the coconut that it has to go down?
No, he's talking about a footballer hitting a ball. There's a cause,
but
and
we
there's
can
a direct.
identify it. That's the whole point.
Yes,
it's
what you're
the
arguing,
guy
Mark,
that
is that the football can be kicked without a kicker.
No, you're arguing that.
No, I'm not.
Oh,
I'm saying that there has to be a kicker.
There has to be a force to make that ball move.
Right. So prove the force, which is what I've said from day one. Where's the gravity?
No. My saying, what I'm also saying to you is that you cannot identify every force. You cannot identify the wind.
There's no force.
You cannot see the wind. You cannot
claim there's a force if you can't identify it.
Well, say that again.
You cannot claim there is a force unless you can identify it.
No, that's bullshit.
No, it's not. This is the reason why I've got an issue with Darwin.
You hesitated when you started to think about wind, didn't you?
No, that's fair. But you can identify it in other ways other than optically. You can stick voltmeters on a thing. But the point is, you can identify the force.
You can feel wind.
Yeah, when you
I was gonna say that you can feel wind. So
yeah, you can identify wind.
And you can feel gravity. And you can feel gravity. If you jump out of a window,
no, that's not true. You cannot feel gravity.
You're feeling your own density, Mark.
So it's a poor argument to say that you can feel the wind, and I say to you, you can also feel gravity. It's a poor argument. One does not.
Where do you draw the line?
Because you can't.
And with that, I'm going to say first and foremost a huge, massive, enormous thank you to all of the live audience for tuning in and hopefully sharing this debate. And of course, a massive thank you to all of the debating panel for making this debate possible. If you hated the show, then you know exactly what to do. But if you like the show, maybe consider sharing it with a friend or subscribing if you have not done so already. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!